So now in this video, we're going to take my power supply here and look at the current that it displays, that it says it's providing a circuit, and compare it with a multimeter that we're going to put in the circuit. So we're also going to use a 5 ohm resistor plus a 1 kilo ohm resistor coming up. But first we're going to look at the 5 ohm resistor. We're going to put 5 volts across the 5 ohm resistor. If it's actually 5 ohms, it's actually slightly higher. All of my 5 ohm ones are like 5.2, 5.3 ohms according to this meter. So it's slightly higher, plus there's a little resistance with the wires there. So mathematically we should get 1 amp of current, but due to the extra resistance in the wires and the extra resistance in the resistor, because it's not perfect, it's going to be a little bit lower. We'll see that. So I'll put this down here, that wire, and then the other one I'm just going to put to a blank row. We need to close the gap with the meter to get our current measurement. And there you can see that this alligator clip comes from the power supply, goes to the red rail, and then I have a jumper that jumps across there. This is the black. You can see the wire there. The black alligator clip right there to a blue jumper that's plugged into the blue rail on both ends. So there's also a little jumper to bring that negative side of the power supply over to the blue rail over there. Now we are going to set the meter to measure current. So this is going to be a higher amount of current. We want to put it in the 10 amp range, and we're going to turn the dial to current right there. That's what we need to measure it with the meter. This automatically measures the current that it outputs. So we're going to see how close those two numbers align right now. So of course no current's flowing because we have an open right there. We're going to close the circuit, and there you can see looks like probably about, I don't know, 5.5 ohms or something based on the resistance, but looks like resistance goes down a little bit as things heat up. But there you can see we're about maybe 4 or 5 thousandths around there difference. So they're pretty much the same number, but you do notice that looks like the multimeter is slightly lower in this case. Now the circuit itself will determine the current that flows, but the current, they are in series. The power supply is running current. We're going to go positive there to the jumper, to that side of the resistor, and then over to there, and then through the meter, through the two probes there, right there. It's going through the meter and then to the negative rail right there, where it goes back to the power supply. It's one path, and when current has one path, it is the same in all parts of the circuit. It doesn't have different areas where it's higher and lower like voltage does. So if both of these were perfectly accurate, they would have exactly the same number. But these are also really close too. So not a big deal when we are close to the amp range. So I feel pretty confident this being really accurate in the amp range. So now, I let the resistor cool down a little while. We didn't run current through it very long, so I didn't wait very long. Also, I should have turned the meter off right away and got it off of the amp setting back to voltage setting right there. Also, we're going to measure milliamps coming up, and so that is the right spot for it right there. So we are pretty much ready to go. So here we have a 1 kilo ohm resistor. In fact, since I have the meter there in this spot here, we can just measure the resistance of this resistor here, because it goes to the jumper. So polarity does not matter here. There's no power going through the resistor other than I have the meter set to measure voltage. I needed to set it to measure resistance. So all the power going through the resistor is from the multimeter, and it looks like it's pretty much spot on 1000 ohms, so that's good. We can also go to this jumper because it should have no resistance. There you can see 1000 ohms of resistance, so it comes to a dead end. The only current path is from the meter, so it puts a voltage across it, looks how much current goes through it. There's the resistor setting, by the way, and based on how much current goes through it, it does the Ohm's law math where it figures out its resistance. Pretty straightforward. Now again, we can leave the probe. We have to leave the probe in the same spot to measure milliamps of current. So we're going to do that. We're going to do the same test we did with the 1 kilo ohm resistor to look at the current on this display versus this one. So here you can see this is milliamps. So the 0 here is the same as the 0 there. And so this should be more accurate. And we're going to see how close they are. So there you can see all we got is 4 over there, and we got 4.95 here. So basically 5. And this is doing better than it was earlier. We are about 1/1000ths off. So it's about 5, but you do see 4 there. So it's not too bad right there. That is at 5 volts. Now with the 5 ohm resistor, we didn't want to put really more than 5 volts across it. And the 1 kilo ohm resistor, since it's limiting current so much, we can raise the voltage a fair amount. So let's go to 10 to start off with and see how well they are holding together right now. And there you can see 9.93, and we got 8. Okay, now we got 9 right there. So it's doing pretty good. I actually tested this out a little bit earlier, and it wasn't doing so good. Now we're going to really, I think, start pushing the maximum wattage of this resistor, but we're going to do it for a brief period of time. And this may still be safe, but this is probably really close to its maximum wattage right there. And so yeah, there you can see pretty much 15 milliamps. We did hit 15 milliamps, and that one says 13 milliamps. So the precision is a lot higher with this one, and the accuracy, I'm guessing, is also higher than this one. So the precision, you can see we got 2 more digits, because this 0 there is that 0. So this one has a couple more zeros to the right than that one, but that's really the only setting for it, which makes sense. This is a power supply. It can go up if you are low enough voltage to almost 4 amps. When you get up to the 30 volts, that's when you run into this 1.6 amp limit. That's at 30 volts, but at lower voltages you can get a higher current. But in case, it's really meant for the amp range for taking measurements, not so much the milliamp here, although it can provide milliamps of current, of course. That's no problem. But in any case, this let me know that it's only about a couple milliamps off, even though it's in the amp range. So it looks like it's just a tad bit low. So if I add a couple, 1 or 2 extra digits to what's displayed on there, I'll probably have a really good estimate of the current a low current circuit is providing. So in any case, hopefully you found that interesting. And I was a bit curious. I mentioned this in a few of my other videos of how accurate the reading was on there. And it looks like it's really accurate, but just a tad bit low on the milliamp range. So otherwise, I think it's doing pretty good. So thanks for watching. I will see you in the next video.